Well, welcome everyone to the 2020 Yampa Basin Rendezvous, the dialogue on measuring and managing seasonal variability. It's a pleasure to have all of you here today, and I'll get us started. My name is Nathan Stewart. I'm faculty at Colorado Mountain College and a Yampa Basin Rendezvous steering committee member. Welcome. In the spirit of the collegial face-to-face meetings and reunions we would be having with one another if we were together in person today, we'd like to take a moment to identify the diversity of professionals and community members in attendance. So I'm going to advance here for a moment. Anna, perhaps you could move me forward one slide. Awesome. So we'd like to take a moment to thank our steering committee, and folks may actually be able to see our poll results as they're up here. We've got some significant diversity spread out across these sectors: science researcher, education, academia, community members, nonprofit organizations. Wonderful to have you all here. So we'd like to take a moment to thank our steering committee. And I'll mention our team first by first name here. We work together very closely, so I trust it's okay that I do so. They are Matt, Madison, Tim, Lindsay, Tony, Marty, Anna, Mike, Kent, and Sarah. This is an incredible group, deeply passionate about snow, water, weather, climate, and community resilience in the West. They're also deeply dedicated to the Rendezvous and its dialogue, and its importance to the West and its future. We'd also like to thank our partners. I'll let you read them on this next slide. Our collaborations continue to grow, and we look forward to expanding them further in this current Rendezvous year. We'd also like to recognize our students. Many in attendance here today are in pursuit of their degrees. 14 are enrolled in a course created in conjunction with the conference. Their course textbook consists of 2019 and 2020 publications from numerous YBR colleagues, including Marty, John Rutz, Mike Dettinger, Jeff Deems, and others. And if you could move forward, we could highlight those students in their class here. This is an up-and-coming class of scientists we'd like to recognize. They are that, practitioner scholars, and also change agents. And each one is essential to this year's dialogue and those dialogues forthcoming. So welcome YBR students. Very briefly, before we begin, I'd like to highlight our webinar format for today. So we're likely all familiar with the general Zoom setting here. I want to make us aware that we're recording the webinar, and that shortly after our meeting here today, we'll post it to the Friends of the Yampa webpage. Please find that address here. Conference attendees are automatically muted, so you need not tiptoe when you refill your coffee, but we do encourage you to participate as you would in a face-to-face conference. Please do send your questions to our panelists. To do so, we ask that you use the communication icons at the bottom of your screen. Highlighted in green text is our go-to function, Q&A. Post your questions here as they occur to you. We'll prioritize them in our post-panel Q&A session. Note that text entered here is visible to all. A silver lining to Zoom is the rich interaction that occurs in this area. Please do post your questions as we proceed. For those joining us by phone, press *9 to post a Q&A. A second icon we encourage is this one. Click raise your hand to queue up and ask your questions live during our post-panel session. You can queue up at any time. We'll virtually hand you the mic when we arrive to our question session. We hope that many of you will opt to do so. Reserve your use of chat for technical questions related to Zoom, audio, visual, or other. All right, now the fun stuff. Without further ado, I have the honor of introducing our opening keynote speaker. It's my pleasure to welcome Dr. Carrie Hauser to the 3rd annual Yampa Basin Rendezvous. Since 2013, Dr. Hauser has served as president and CEO of Colorado Mountain College, a public institution enrolling nearly 20,000 students annually at 11 campuses in the Central Rocky Mountains. Previous to CMC, Dr. Hauser held leadership roles at the Kauffman Foundation, Metropolitan State University of Denver, and the Daniels Fund. Dr. Hauser is currently a governor's appointee to the Colorado Parks and Wildlife Commission, a member of the Great Outdoors Colorado Board, and El Pomar Foundation, Northwest Regional Council. At the national level, she serves on the American Council on Education Board of Directors and is past president of the National Scholarship Providers Association. Dr. Hauser's prior board service includes, among many, American Rivers and the Glenwood Springs Chamber Resort Association. Two previous gubernatorial appointments were to Colorado's Blue Ribbon Commission on Healthcare Reform and the Colorado Commission on Higher Education. She's been recognized as the 9 News Leader of the Year and one of the 50 for the future of Colorado. Dr. Hauser's background includes teaching assignments at UCLA, the University of Denver, and Colorado State University. She's held research and legislative staff roles as well as positions with the Western Interstate Commission for Higher Education and the University of Arizona. She earned her master's and PhD from UCLA and is a graduate of the Advanced Management Program at the Wharton School of Business. An avid outdoorswoman and athlete, Dr. Hauser has summited Mount Kilimanjaro, raising funds for student scholarships, climbed to the Mount Everest Base Camp, and held the proud title of Swamper while working many summers for Hatch River expeditions in the Grand Canyon. It's our sincere pleasure to have you here with us today. Please join me in welcoming Dr. Hauser.
I think I'm unmuted. There we go. Thanks, Nathan. I think I'm unmuted. Hopefully everyone can hear me. I'm really glad to be with you and so excited that we're together again. This has been a must-attend event for me every year. I always appreciate having it on my calendar, and am very grateful to the planning committee and everyone else for sort of rowing against the tide, so to speak, and making sure that this happened even in this current environment. So, so grateful. And I want to say thanks to Kent, certainly, for all of his efforts. And I will just underscore Nathan's designation as Faculty of the Year for the entire college. That is by no accident. That is something that is socialized by our internal stakeholders, students and faculty and others. And so it really is quite an honor. So if you can see behind me, it's also no surprise that my Zoom background is the Roaring Fork River. You can see Mount Sopris in the background as well. All of these tributaries obviously dump into the Colorado River, and we'll talk about that a little bit later today. But rivers connect us in so many different ways. So I'm glad to be back with you and really excited about this. So I'll offer a few points of data. Nathan helped me with these. And I suspect most of this is preaching to the choir, but I think to kick us off, it certainly makes sense to underscore some of what we're facing. And the first is, we know that 2020 is on track to be the Earth's warmest year since 1880, and that's according to NOAA. Washington Post reported in April, there's a 75% chance that in 2020 we'll set a record for the warmest year since instrument records began in 1880. And NOAA is projecting beating out 2016 for that distinction. This is somewhat unexpected given that there's no declared El Nino event in the tropical Pacific Ocean, which tends to provide a natural boost to global temperatures that are already elevated due to the human-caused buildup of greenhouse gases in the atmosphere. Secondly, a latest report from the Intergovernmental Panel on Climate Change, or the IPCC, included a specific focus on high mountain areas and underlines the magnitude of associated climate impacts and risks and the urgency with which we need to identify adaptation measures and to take action. This report includes observations on changes in the cryosphere, which includes snow, glaciers, permafrost, lake, and river ice. The cryosphere is a key element of high mountain regions like ours. Approximately 10% of the world's population lives in these types of regions, and impacts on the cryosphere are ever seen as far as an ocean away. Among these observations in the report are general declines in low elevation snow cover, glaciers, and permafrost. These declines are caused by climate change in recent decades. Third point I would make today is that the Colorado River, as we know, is in crisis with far too many straws in the drink, so to speak, too many demands diminishing its flow. And I was asked to offer sort of a personal note of why rivers are so important to me. Nathan mentioned in my bio that I just recently finished 2 terms on the American Rivers Board, a national organization whose primary interest is in protecting rivers across our country. And I co-chair the Colorado River Council currently. I grew up in Flagstaff, Arizona, and my connection to the Grand Canyon and Colorado River were very dear to my heart. And ever since then, I have tried to be a champion of the Colorado River, and certainly the basin and the tributaries that flow into it. This weekend, in fact, we will launch Saturday morning. I'm doing just sort of a quickie, Ruby Horse Thief. So I'll be on the Colorado this weekend and try to make that connection as often as we possibly can. My husband and I are looking forward to that. I also would just note that there are some triumphs as we move along. There's been some recent really good news about the Gila River through New Mexico, and the American Rivers every year publishes a most endangered list, and so I would encourage you most endangered rivers lists. I would certainly encourage you to seek that out if you're interested in some of the other urban rivers and others around the country that are also under siege and that we're trying to make a difference and protect those. So Jim Robbins wrote in a January 2019 article entitled "The West's Great River Has Its Limits. Will the Colorado Run Dry?" This was published in Yale Environment 360, which was published by the Yale School of Forestry and Environmental Studies. And here are a few things that were out of that article. The Colorado River Basin has been locked in the grip of an unrelenting drought since 2000, and the 2 great water savings accounts on the river, both Lake Mead and Lake Powell, are at all-time lows. I will share that a couple of weekends ago, my husband and I did a sort of an off-grid long weekend through Bears Ears, and we ended up over in the Glen Canyon recreation area and hiked marina. And it's still, even though there's been some progress in the levels in both of those lakes, they are incredibly low. And to see it in person and to see how far the river is down, really the lake is down from the boat launch is really striking. I have mixed feelings about that because in some ways, no crisis, we leave no crisis to waste. There's some really important lessons, it would seem, to see that and to understand really visually the impact of drought and the taxation on the Colorado River. Most of the water in the Colorado comes from the snow that falls in the Rockies, as we know, and is slowly released over months. But since 2000, the Colorado River Basin has been locked in a long-term drought exacerbated by climate change, as we know, the most severe drought in the last 1,250 years. Scientists believe a long-term making things more arid, I will say, driven by climate change, may be taking place and permanently drying the West. Fourth point I would ask that you keep in mind is the declining snowpack has led to a 20% reduction in the Colorado River's annual average flow compared to last century. As recently as February 2020, the Washington Post ran an article with this headline: "Climate change has stolen more than 1 billion tons of water from the West's most vital river." 4 different studies have shown that since 2000, the drop in the Colorado River's annual flow has been driven by warmer temperatures. And 2 U.S. Geologic Survey researchers say that much of the decline is because of the region's snowpack is shrinking and melting earlier. So what does this mean for the immediate future? The Colorado snowpack was average to above this past year, but the distribution of snow was notably uneven. And I would just say, as my own editorial comment, we get really big snow years, and then sort of we all sort of the general temperature for observing and monitoring these issues becomes less urgent. And I think part of our job is to make sure that it stays top of mind. Our 2020 summer stream flow forecasts are lower than average and are a statewide concern. Multiple years of drought have left us with dry, thirsty soils, and a hot summer in 2020 is certain to contribute to increasing evaporative loss. So I would just say as climate changes and the past becomes less of a guide for our future, we need more accurate understanding of snowpack and how water snowpack will yield. Enter COVID-19. And I would say it would be amiss to not also mention the inequities across our country and the connection between climate change and some of the civil unrest that is occurring currently. We know the health disparities, we know environmental disparities, we know that people of color and those that are living in urban centers more impacted by environmental change and some of the circumstances that we're seeing right now play out. So we are facing two pandemics. One is long-term racial inequity, and certainly the other is COVID-19, which is a public health issue. And both of them are both directly and indirectly tied to climate change and all the things that we're seeing in our broader environment. As we all know, as we've been shuttered inside and there has been less use on vehicles and manufacturing and all the things that we understand, our environment has responded. And my hope as we come out of this current period is that we do not go back to normal, is that we really understand and take lessons from what we've learned and find the silver linings in how our environment has responded to less human use of our wild places. So I would just sort of end with water management requires an understanding of the extremes, the wet years and the dry years, which are getting drier. And I'm very pleased that we'll have some noted speakers to address some of the issues we've raised today. They will explore the science behind projected changes in precipitation and temperature patterns and their effects on resource management, the ways we monitor and measure these changes, and whether or not our existing systems are capable of matching historical predictive skills. So I am really glad to be here. I'm happy to stay on to the extent I've been seeing the chat come up, but I have not been monitoring that. So Nathan or Kent, if there are questions that came in, if anyone would like to have any kind of dialogue with me, I'm happy to stay on for a little bit. And I also know that you have a big agenda ahead. So you just cue me as to what would be most helpful for the audience that's listening in today.
Excellent. Thank you, Carrie. Great kickoff to this year's dialogue. I'd like to invite our panelists forward here to follow some of those points raised. I'll introduce each of them in sequence. We'll bring up their bios here in a moment. I have the pleasure of starting with Dr. Marty Ralph, and we'll do so here. Marty is the director of the Center for Western Weather and Water Extremes, Scripps Institution of Oceanography, UC San Diego. He's a research meteorologist at the forefront of atmospheric river storm research. Marty has 140 publications in the field, and as of this morning, nearly 10,000 citations according to Google Scholar. He is formerly branch chief at NOAA's Earth Systems Research Laboratory in Boulder, is an elected fellow of the Cooperative Institute for Research and Environmental Sciences at CU Boulder. And Marty is the recipient of the NOAA Administrators Award for, quote, exemplary leadership of the NOAA Unmanned Aircraft System program during its formative stages. Marty, it's a pleasure to host you here today, and welcome.
Thank you. It's an honor to be here.
And Marty, I'll introduce Ken following your talk here today, so feel free to jump right in.
So would you like me to go ahead with the presentation?
Yeah, go ahead, Marty, take the floor.
Okay, sorry, I misunderstood that. And Carrie, I just wanted to personally remark what a wonderful opening you made for us in setting the context of all the things that are going on that are relevant to water in the West. And I'm particularly resonant with your background at University of Arizona, where I got my bachelor's degree, and UCLA, where I got my PhD.
I recall that we share that in common. Go Wildcats. Bear down Arizona.
Bingo. All righty. Well, let me see if I can get this technology thing to go here. Yeah. I think I got it on the wrong slide. I got to start over on the share thing. Sorry for fumbling here. Share screen. Here it is. All right. So thank you so much, Nathan, for the intro. And it's so exciting to be part of this, despite not being in person. I think the idea of Yampa Basin Rendezvous from the beginning was to bring people together from different disciplines, different backgrounds, different interests, and to see the Yampa Basin as a catalyst for better understanding our water challenges in the West, particularly with a emphasis on the weather and extremes and climate and hydrology components of it. So I've got a couple pictures here I want to highlight. One is a storm off the Scripps Pier there, beautiful dramatic sky. And the picture on the right, I'm guessing most of you would think is Colorado, but in fact, it's just an hour from the coast here, about 5,000 feet up in the mountains, Big Laguna Meadow. I'd never been there till this a couple weeks ago. Fantastic location. This is more what you're probably thinking about, is the snowy scene of the park range and all. And what I'm going to do here is just give a little bit of programmatic background for a couple slides, and then share information on some diagnostics we're doing on the local variability in extreme 2-week wet periods in and around Steamboat. This is it's related to the theme of the workshop, and also to the following what we did last year. I want to just step back for a second and let you know a little bit more about our center in San Diego, Scripps Institution of Oceanography. Really, the vision is to help provide natural and socioeconomic systems more resilience to extreme events. And here we see the Oroville flood event where the spillway was damaged and there were 200,000 people evacuated. That was a big atmospheric river back in 2017. But also, as we can see in the lower right, this is the color basically represents the variability year to year of precipitation. And the southwestern US is just far more variable than elsewhere, by a factor of 2 or even more. So we need specialized tools and knowledge and systems to help support decision-making around water in the West. And then the mission of our center is really to advance the science, the technology, the education and outreach, to support decision-making and deal with the extremes that we face in the West. So when starting the Yampa Basin Rendezvous a couple of years ago, reaching out to Colorado Mountain College and being so well received and so welcoming. Nathan, congratulations on your recognition for your role in teaching for a big institution, CMC. Congratulations on that. It's been a wonderful relationship, and I feel like we're in a really sweet spot on that. For our center, we just launched a few years ago. We've just updated our strategic plan. We've got strategic priority areas, which includes subseasonal to seasonal prediction of Western weather and water extremes, which is really a focus of our rendezvous here. I just want to highlight that no center is worth its salt if it doesn't have people involved, and this is a shot from a few months ago of about half the people involved. The numbers are just because we have the names on a caption for this, but very diverse crowd of people, early to mid to late career, from all walks of life it seems, and also disciplines. All right, let me now turn to some science. And in fact, this is a photo from someplace. I swear, if someone could tell me where this is, I'll buy you a beer next time I'm in Steamboat. So the question I want to get to is a bit about the extreme events in the northwest part of Colorado. And this diagram shows a finding from the study by Rutz et al. A few years ago of pathways of penetration of atmospheric rivers inland in the western US. ARs produce about half of the precip on the West Coast, but as you go inland, the fraction gets less and less. On the West Coast, it produces most of the floods, and as you go inland, it gets less and less. But the tools needed to really diagnose that are a little bit under development still. And notice how those arrows don't reach all the way into Colorado. Having lived in Colorado for 20 plus years and visited Steamboat for decades, I'm skeptical that this result is actually accurate, in the sense that I believe ARs actually make it into Colorado and contribute to some of the extreme events. We've poked around a little bit on that last year at the YBR, and we're expanding on that here. And Kent and I have coordinated a little bit our presentations around that. So this is essentially the previous result, the theory and observations that support it, but we think there's more going on, and I want to share a little bit of what we're doing in that regard. First of all, back in 2018, I happened to be in town, and there was a very wet storm. It snowed all the way to the top of the ski area, it rained all the way to the top of the ski area just in early April. And those you see the headline in the local paper, and it's cool that people are using, atmospheric river in the jargon in the media now, and the Weather Service and all. And in the lower left, you see the colorful images of the atmospheric rivers, of the atmospheric river that hit the coast prior to this rainfall event. ARs tend to be warm and very wet, so they are, places where, or storm types where we expect to get, potentially, very wet snow or even rain, off season. All right, if we go to last year, there was a very interesting exchange with Kent Vertrees. This is from a blog he posted about a year ago of a big wet period, and made mention of, one of the top wettest, 2-week periods. They had tallied 114 inches. Well, that got me thinking about this idea that, studying an individual storm is helpful, but it's also good to study longer periods. So this 2-week period seemed like a sweet spot. So I asked Kent if he kept, if he could share those data. And here's his charts he has, which are just fantastic. I used to do that sort of thing. And then here are the dates, the top 10. So this triggered some analysis by Zhenhai Zhang. Mike Sirks is on the phone, and I did some last year. And I want to report on that a little bit here. So I've got a, sorry, the congestion is not the COVID thing. I want to share some technical results from Zhenhai Zhang, staff scientist here, and myself. We did following that identification of those 2-week wet periods. First of all, those were from the Steamboat Powdercats cabin that is in their area, and it's just a few miles from the tower snowtell site. And here's a map to navigate, and thanks to Kent for this beautiful view. And what a landscape. Many people on the call know intimately. Steamboat on the left, Rabbit Ears Pass down here. Notice the pin, that's a snowtell site. And here's the tower site. There's the Powdercats area. There's the ski area. So we're going to poke around on this a bit for the next few minutes. First of all, I want to highlight that those two snowtell sites are really just 10 miles apart. They're right next to each other. There are 1,200 feet higher, towers 1,200 feet higher. So first thing I wanted to do was find out, how much the snow varies from the two sites. It's pretty easy. You just go online to the snowtell site. But I wanted to highlight that a couple of things. First of all, that the average accumulation rate for snow water equivalent, the vertical axis is snow water equivalent, is about 2 inches a week at Rabbit Ears and about 4 inches a week almost at Tower, nearly double. And notice how steady it is when you average over decades. Although there is this very interesting thing right around New Year's. That's a funny dry period right after Christmas, and a very wet period right before Christmas. Notice that's a little steeper. Also like to highlight that if you look at the beginning, the SWE starts accumulating at Tower about 2 weeks before it does so at Rabbit Ears. And the accumulation continues a bit later, about a week or so at Tower. So part of that snow accumulation maximum being nearly double on average at Tower than it is at Rabbit Ears is both because the rate of increase through the winter is higher, but also because this accumulation season on average is almost a month longer. That 1,200 feet really matters. So let's, the next question we wanted to ask is, what were the top 10 wettest 2-week periods in the 20-year period that Kent had shown data from at the Powdercats cabin site? So here are the dates for Tower. And these are the top 10 wettest periods over the last 20 years, starting with water year 2000. You see there were 3. Then 03, 04, 06, 14, 17, 19, and 20 each had one of the members. Now let's look at Rabbit Ears, their top 10. And remarkably, to me, only 3 of those periods overlapped. These are only 16 kilometers apart. What the heck's going on? I don't have the answer to that yet, but it's really an intriguing question. And as we're thinking about seasonal and subseasonal, forecasting and all that, to be able to distinguish, when these wet periods are going to hit one spot versus another in these complex mountains is a major technical challenge. But because of the importance of the water, it warrants, I imagine, quite a lot of effort to try to solve that. So let's dig into these events a little more deeply. First of all, what time of year do they occur in? Here's the summary of those two, from those two sites. The top 10 events, the blue, are from the Tower site. And notice January and February have, quite a few, 6 of the 10 are in the January-February timeframe at Tower. But notice for rabbit ears that 6 of the 10 are in March and April. They're completely different months. So we have a very different climatology, not only in the amount and the dates, but even in the seasons in which these wettest events occur. What do they look like in terms of the total contribution to annual SWE? Here's the composite of the 10 events. The blue is the Tower top 10 2-week periods, and the green is the rabbit ears. First, let's follow the blue curve from the bottom left. The vertical axis is the snow water equivalent, anomaly relative to 0. We set 0 as when the 2-week period started. And notice the steep ramp up over the 2 weeks right there in the middle. And that's almost 10 inches of snow water equivalent, which is, if we go over here, 19% of the average annual SWE. So about a fifth. These top 10 events, each on average produced about a fifth of the maximum average SWE per year, just in 2 weeks. And at the rabbit ears, the green line goes up similarly steeply, but not quite as much, 6.6 inch average in 2 weeks, but that's 300% of the normal rate and produces about a quarter of the maximum SWE average per year. Notice sort of an interesting thing here, how there's really not much accumulation prior, so it's basically dry for a few days ahead of the wet period, and then it sort of is dry afterwards. But notice also rabbit ears is very little accumulation after that, whereas Tower really ramps up. That's because the Tower events are largely in the January-February timeframe, and there's plenty of time after that for more snow accumulation, whereas rabbit ears is in March and April, near the end of the accumulation season. So we see a lot of divergence there in the accumulation post-extreme event. And I just want to sidebar for a second. Our work on atmospheric rivers was motivated partly because over many years of watching the weather in the West, I had noticed, as I'm sure many had, that a big fraction of our annual snow and precip comes from a few big storms each year. I had a rain gauge when I was a PhD student, Carrie, at UCLA, and in I was there for drought years, sadly, but one of those years we got half of the rain for the whole year fell in 6 hours. And it just really struck me, what an important part of the water cycle those storms represented. So that's almost 35 years ago now, and I'm still pursuing the same thing. I guess I'm stuck in a rut. Alrighty, so we've got the analysis here. Now let's take a look at the top few wettest days within each of those two and take a deeper look at those. So for Tower, these are the specific dates that had the maximum snow water equivalent increase. And you can see they're 2.5 to 3 inches. And the rabbit ears associated increase was pretty good, about 1 inch. And then for the rabbit ears top 10, we have the top 10 2-week periods. The top 4 wettest days within those top 10 2-week periods are about 2 inches. And Tower is about, a couple of them were quite low, and a couple of them were pretty good there, about 2 inches. So we're just going to take a look now and see whether or not atmospheric rivers might have played a role in these. We've narrowed it down to a few enough cases. We have the time to actually look at that and share in a presentation like this. And this is the beginning of what I would say is a research path where we will do a much more thorough job than I'm presenting here. But this is sort of how I've learned to do science, is interesting result like Kent's table, handwritten. What are those 2-week events like? Well, let's look at it a little more. So we find these 2 sites, and now we're looking at the top 10s. And anyhow, we narrow it down so we can, without a huge amount of time, make some initial steps. Alrighty. So this is a nice diagram from Zhenhai Zhang. What is an atmospheric river? It's essentially a river in the sky. That blue ribbon is meant to convey that they're fairly narrow, on average about 500 miles wide. And they flow over the mountains where they create heavy rain and heavy snow. I'm going to introduce jargon here called IVT. It's the vertically integrated water vapor transport. Imagine you take wherever you're at and go all the way up through the atmosphere and calculate the horizontal flow of water vapor being pushed along by the wind. It's a little bit like the flow of liquid water in a terrestrial river, but it's water vapor in the atmosphere above you. And this parameter, IVT, is the measure of that. And the map on the right shows a color fill of different values of that. And the yellow and other colors are what we now know as an atmospheric river. And notice in this case, we have red colors coming into Washington, and even the yellows all the way into northwest Colorado. And the vectors tell you what direction that water is flowing. So notice that that's basically flowing right into Steamboat. And this is from this last February, one of the big events that you'll hear about from Kent in a few minutes, and one of the events we're looking at. So here's an atmospheric river all the way out from near Hawaii, flowing up over Washington, Oregon, and into the northwest part of Colorado and dumping a ton of snow. I won't go into it in this talk, but I also run the Atmospheric River Reconnaissance Program. And out here, we were flying 3 research aircraft from the Air Force and NOAA to measure these storms to try to improve their prediction of landfall. This storm actually produced pretty serious flooding up in Washington State and Oregon, and we're working now to analyze the impact of our data. We already know it's having an impact. We feed it into the operational weather prediction models globally, and essentially we are establishing an operational winter season atmospheric river reconnaissance program over the East Pacific. It's formally now funded by Congress. It's formally required by the federal agencies, and here at Scripps, we are co-leading it with the National Weather Service. Another thing we do is we calculate how much water that is relative to the Mississippi River in this case. And here, imagine we're cutting across the AR, and it turns out you calculate the amount of flow of water vapor. It's about 14 times the flow of the Mississippi River on average. So we've essentially got 14 Mississippis of water vapor flowing into the Pacific Northwest coast, some of which is making it into northwest Colorado. And then we can add that up over time, and we call that time integrated IVT. And here we have a 1-day time integral, and that tends to help clarify a few things when we look at that carefully. And the figures I'm going to show you now, very rapid fire, are the 8 daily events that we looked at a moment ago that were extremely wet in northern Colorado, or in the Park Range, and we're going to ask the question, were they an AR or not? Now, I'm going to use my judgment from experience, and I'm just going to tell you whether they are or not as we go through. So here's one. This is clearly a strong AR coming into California. In fact, it hit California very hard, and it looks like it made it into northwest Colorado a bit. So that's a yes. And this one's also a yes from 2005. This one's a yes, a little wider in the northwest, but still AR conditions. This is another yes in through California. This is now the rabbit ears event, number 1. This comes in through the northwest. And also interesting, it has a bit of a gap there in Oregon, something we'll study. This is a very well-defined one I just showed you a moment ago, in through the northwest. This is not an AR impacting Colorado. And this one is not either in terms of the northwest part of Colorado. So the punchline is, yes, most of these, 6 of the 8 had well-defined AR at the coast, and in some of them, clearly they penetrated into the Steamboat area. So I just wanted to highlight that we're looking at this because partly the upper Colorado Basin is really important to water in the West in general. Our center is focused on Western weather and water extremes. Our interest was triggered a bit by the Yampa Basin Rendezvous in 2018, and Kent Vertrees' handwritten data got us thinking differently, and now we're working on analysis, as you can see here. But getting snow on the ground is not the whole story for water supply, of course. It has to melt and get in the rivers, but soil moisture can be dry going in. There can be a lot of straws sucking water out. There can be sublimation in the winter, meaning the ice goes directly to vapor before it even melts. So let's take a quick look at Lake Powell, and then I'll be done. So this is Lake Powell snowpack above Lake Powell over this last winter in the black line. And this is going from November 1st to June 13th. And the dashed blue line is the mean over many years. And notice in April, it was above average by about 10%. But then notice how steeply it dropped off, and it's been well below average ever since then. So there's a lot of melt going on. And I think what Carrie highlighted is conclusions are that the temperature is playing a big role in drought in the West. I think that's in play right here. We're going from above normal snowpack, which, by the way, warmer air holds more water vapor and can make more precip. but it melts faster when we turn on the spring sun and change the climate around that. Well, how's the lake doing? You know, it looks like we should have a huge boost in water level in Lake Powell, right? Because this is above normal and it's melting faster than normal. Well, how's Lake Powell doing? Oh my gosh, it's barely creeping upward. It's not doing so well, if you ask me. You can look at, these are 5 different years. Look at the green curve from a couple of years ago. That was 2017. The yellow curve from 2015. This is the slowest ramp up other than this one very dry year. And yet it started with above normal snowpack. And that previous graph, that was not just the Yampa. This is the entire snow water equivalent average above Lake Powell. So something serious is going on, inhibiting the amount of water getting into the lake. And it's not just because it's flowing slowly through. The lag time isn't that long. There is a surge coming right now, so hopefully these water levels in Lake Powell will do a bit better in the next week or two. But clearly something else is going on to inhibit transformation of that good, healthy snowpack into the water that many people depend upon in the rivers, even before they get to Lake Powell and then when they do get to Lake Powell. And finally, I just want to really say thank you again to the organizers and for participants for the chance for us to work with you, for folks in my center who are joining in. Thank you to Zhenhai Zhang for your input and analysis in this. So I'll stop sharing at this point, Nathan, and turn it back to you.
Excellent. Thank you, Marty. We look forward to our question and answer session with you following our second panel. Conference attendees, keep those excellent questions coming in. I'd like to introduce our second invited panel speaker here now. We have the privilege of welcoming Kent Vertrees here today. Kent is president, excuse me, of Friends of the Yampa, and is a local, regional, and statewide river leader, advocate, and steward. He's the acting recreational representative to our Yampa White-Green Basin Roundtable. His leadership was essential to the Roundtable's non-consumptive needs assessment, which identified priority reaches in the basin based on their environmental and recreational attributes. Kent is an adjunct professor of outdoor education at Colorado Mountain College, where he teaches river and canyon orientation courses. Kent also serves as manager of Steamboat Powdercats, Northwestern Colorado's only snowcat skiing operation. Kent, welcome. It's a pleasure to host you here today.
Thank you very much, Nathan. And thanks, Marty, for a great talk. That's great. Let me get my screen going here. And so really appreciate it. Very happy to be here and give everybody online today a basic review of the hydrology that we've seen from our last Yampa Basin Rendezvous last June. So I'm going to cover what happened last summer, cover this winter, and then really give another idea of what's happening this coming summer. So first off, I want to just remind people where we are here in Northwest Colorado. I know we have a lot of smart folks online looking at the presentations today, but for those of you who don't live in Steamboat, the Yampa River is 250 miles long. It originates in the headwaters and the flat tops and the Park Range, which is this area. We do have the Yampa is widely known as one of the wildest rivers in the Colorado River system because of the big snowpack and annual runoff that Marty alluded to. Notice the 3 reservoirs that we do have. Stagecoach Reservoir is a main stem reservoir, but up here in the headwaters, the river's running really low, or really, it's a really small river up here compared to where we see the Yampa enter into the Green River in Dinosaur National Monument. The Yampa just becomes a really big river. The story of the Yampa is that we don't have much reservoir storage, and therefore the flows get in the river, flood the banks, provide those ecological services to the actual endangered habitats, the endangered fish, and other species, all the way down through the Yampa Basin, and then even into the confluence of the Green, and then all the way down to Lake Powell. The pulses of the Yampa River are very important for a lot of reasons. Taking us back to last year, we were sitting in a really good place come June. If for those of you who attended the Yampa Basin Rendezvous then, we were actually in a really great spot. You can see here at May, we did have great snowpack levels here in Northwest Colorado, about 105%, that then picked up come May. We had a very wet May, which was outstanding for us from a snow status. And the whole state was looking really good. Flash into the drought classifications last year. At this point last year, you see Colorado here. It was the first time in a 20-year period in the state of Colorado that we were not classified in drought for any region of Colorado. We had, again, just a great snowpack last year. Over here is this year, it's a different story, and I'll get into that later in the talk. But last year, we were just sitting really good. Here's our hydrograph from last year, May 1st, basically through the end of the season. You see in early June, we were sitting really good. This is the Steamboat Spring reach of the Yampa River, as well as our largest tributary, the Elk River in green. These rivers really mimic each other. They're about a very similar size at the confluence of the Elk and Yampa River. A little side note about the Elk River is that it's about 1/3 of the watershed of the Yampa River, making it the United States' largest water producer for any river for the size of its watershed. I would love to dig into that more. And if anyone has any time, any scientists out there want to dig into that with me, I'd love to powwow with you longer about that. Anyway, I want to talk about two specific events last year. This one, you see the Elk River spiking at the end of June, and then this one down here where the river hit its base flows, and we had to do some work with the river. So that event in June actually was a snowy event. We got 20 inches of snow in the headwaters on summer solstice. We were ready for it. The weather forecasts were coming in. We knew we were going to get an event, but we didn't know that we were going to have to pull out our shovels and shovel the deck once again. I can remember my kids building snowmen and my dog just loving it. But that was a pretty crazy event. It made national news, and locally it definitely caused a stir for us in the water world, specifically because the Elk River spiked. You see this flow right here. The Elk River basically doubled in size overnight after that snow melted. We had that big storm come in, laid down that snow, and then it melted off basically the next day. You can see, so this is the Elk River, this is Steamboat. We really didn't see much of a real big peak like we did see on the Elk. And you see this is Deer Lodge Park, which is basically the furthest downstream water gauge that we report our water from. And you can see that pulse from the Elk did make it down to Deer Lodge just a few days later. We did have local flooding. It was a hassle for our landowners. Fortunately, it didn't disrupt too much. This did make national news also, having that big snow event on summer solstice. There was reports in CNN, and it definitely made for an interesting hydrologic event for us last summer. Flash forward to where we were at the end of the summer. So remember, we had all this great snowpack. We were set up really well, but then we had a really dry summer. After that June event, things just shut off. Rain did not come all that often for us. And we actually had to close our river here in Steamboat Springs on August 28th. We believe in the city of Steamboat and our community of river advocates that it's important to close the river when we get below a certain level of river. So at 85 cubic feet per second, we start looking at the river, and we then examine also, so it's flow, its temperature, and then its dissolved oxygen. So 85 CFS or below, water temps have to be 75 degrees or above for 2 days leading up, and then the dissolved oxygen has to fall below 6 milligrams for at least 2 days. Anyway, we've been doing this for over a decade. It's great, get a lot of community buy-in, basically trying to preserve the health of the Yampa River. And we had to close it last year for just 1 day. And what happened, why did we only close it for 1 day? Well, we have a great partnership with a lot of community members here in Steamboat. A lot of people are really looking out for the river, and we're utilizing those reservoirs that I showed at the initial slide to release water to help the river health out. So in partnership last summer was the Upper Yampa Water Conservancy District, who of course manages the reservoir. Tri-State, the local power plant, helped by helping move that water downstream. Also, the Colorado Water Trust and the City of Steamboat Springs do a great job of planning and preparing for it. So you can see here on August 28th, this is flows out of Stagecoach. They really ramped up the flows. You see the Yampa picked up those flows. It's just a dozen or so, 20 miles downstream from the reservoir. And then this is below Craig, which is another hour and a half by car, or more or less. And you can see the river picked up significant steam, which is interesting. Wouldn't have thought that the river would pick up the flows from Stagecoach. And you can see with this next slide that at the same time, the flows out of Elkhead Reservoir were also being released. And those are released for a variety of reasons, endangered fish being one of them. And so this is the flows out of Stagecoach on that day that really benefited the Steamboat Springs reach of the Yampa. These are the flows out of the Elkhead Reservoir, and lo and behold, bumped up the flows downstream of Craig. So I guess the take home here is that even with the big snowpack, we're not out of, out of our reach to get really low water and drought here in Steamboat. And then we do utilize these reservoirs to help us bump those flows up for a variety of reasons. Yeah, and here's that slide. So we had an above average winter, spring precip was near at average. It really set us up nicely. We did have a cool spring, so the snow melted. Our irrigators were happy. Had a lot of good hay production. And then after that June 22nd storm, we really didn't see much rain, and therefore we had to close the river and then work our partnerships and those highly beneficial releases out of the river to really bump those stream flows up. And thank you for everyone who's involved with that. It's outstanding. Heading into this winter, so our first major snowfall was in October 10th. We actually had 7.5 inches. It snowed all the way down to Steamboat. A lot of times that doesn't happen. To remind you guys, the Park Range is the snowiest place in all of Colorado. These mountain ranges just block the snow, similar to what Marty was talking about. And it's evident by our snow, or our water flows in our rivers. You see the Yampa is the 3rd highest producing river in the state of Colorado. Of course, the main stem and the Gunnison coming in here, showing how much water we get. From a meteorological standpoint, southwest flow for us isn't great. You see here, when the storms are coming up from the southwest, areas like Wolf Creek get a lot of snow. This is like a catcher's mitt for snow when those storms are coming up. When we get southwest flow, the flat tops block the direct hit. They kind of accumulate the snow before it comes into Steamboat and the park range. We love northwest flow here in Northwest Colorado. As those storms come down in from the Arctic, it's really nice, producing great snows for us. And you can see it here, direct shot from the northwest, comes across the Great Basin where it's really dry, arid, comes across the mountains, but then when we get that northwest flow, makes all of us skiers really, really happy, and water professionals. It's good. Orographics play a big part in our local snow accumulations. That's when the snow or the storms come in, bank into the mountains, and they sit and spin, and they dump snow on us, basically producing little microclimates of snow. When we see orographics on the forecast, we're really happy. And one last graph of showing our snow. So this is the park range again. This is the snowiest place in Colorado, park range, the Elk Mountains by Crested Butte, and then the purple here down by Wolf Creek. So back to our highly scientific maps that we created, or graphs that we created, Steamboat Powdercats. This one is this year, and I want to highlight these storm events. As you can see, December was pretty good. We were getting some good snow. We had a little bit of drought here. This was a savior storm right in Christmas. This helped us out, but then it really didn't stop snowing until March. And I want to let you guys know, we did close our doors for Steamboat Powdercats on March 16th because of COVID. I didn't collect a lot of data here. I actually have a more detailed map, but that's not from this picture. We did get snow later in March. Just disregard this. But back to here, we had 4 20-inch powder days this year. And that's a big deal for us. I've been working at Steamboat Powdercats for 20 years. And in those 20 years, we've only had 18 total 20-inch days. So we were blown away by that. It was outstanding to see 4 of these 20-inch powder days happen, because it's a really big deal for us. And you can see here in that 2-week period in February, we actually got 3 of those 20-inch storms. Thank you, Zhenhai and Marty, for helping me kind of dig into these 20-inch storms. Going to the first one in January, you can see that the atmospheric river did hit the west coast, but it didn't penetrate into Steamboat. So it split here, and we didn't get an AR event. Here's our detail that we work with at Steamboat Powdercats every morning. We knew it was storming. We saw the temperatures. They were nice, set up for snow. We did see some SWE up on the tower site and at Dry Lake, so we knew there was snow accumulations, but we didn't know how much snow was up there until we got up there. And this is what we call the Steamboat Surprise. So our friend Joel Gratz came to our Yampa Basin Rendezvous back in 2000, or back in our first Yampa Basin Rendezvous, and he keyed this in. This is where we just get the perfect scenario where we get these epic powder days, which is really dry, super light snow, making for really happy guests, and that just classic champagne powder. Now, secondly, here February 6th and 7th, we did have land penetrating or an inland penetrating atmospheric river coming in. Marty showed this slide. Here's Steamboat. You can see we have some snow or some atmospheric events that did bring that AR inland. And look at our SWE that we got that day. So 1.6 inches of SWE. We woke up that morning. We knew it was going to be a big powder day. And lo and behold, it was. The guides, you see some of the really happy smiles on their faces, but also some questions there, because when we get those big snow events up on Buff Pass, sometimes the skiing's not the greatest. And especially with these atmospheric rivers, this snow is the denser type of snow. So it's really heavy snow or water content. We had 20 inches of that, and it was actually a struggle for us to ski that day. It was not champagne powder. People were in the back seat. they were having a hard time if they weren't really good skiers. Okay, the next big snow event, February 13th, we had not another atmospheric river. So we had a nice 20-something inch powder day. It was beautiful. Woke up with 0.4 SWE on the snow stake. We knew it was going to be snowing, but we again did not expect it to be as deep as it was. And what a great day that was. 22 inches of POW, just outstanding and beautiful. Super light face shots again, just that beautiful northwest flow that we get. And 22 inches of powder makes people's days. All right, now our last big event that we got here in Steamboat was another AR event. So we did have inland penetration. You can see here, nice penetration, and then the residuals from that event. So we knew we were going to get a big day. It was 2.2 inches of SWE. It was going to be intense. And one thing that happened with this storm, and I talked about the snow quality was different. 26 inches scares us up on Buffalo Pass. It's pretty flat skiing in some places. And like I mentioned before, it can be a struggle. But we had some sort of shift in the snow on those last couple layers, that kind of the last snow that fell, I guess it was probably the last 8 to 10 inches, was that blower snow. So we had a deep layer, that dense snow, and then the last little bit of that drier snow. So we were happy. Life was good, and it's pretty wild. Again, 4 20-inch powder days this winter, where we've only had 18 in the past 20 years of us keeping records. All right, now going into where we stand today with our snowpack. I want to point out down here, early March this past year, we were doing pretty good. You know, we were above snowpack levels in the northwest part of the state. Good snowpack more or less throughout. May, we were still good in the northern part of the state, but we started seeing the trend of us losing our snowpack. And then of course, here's where we sit today, where we are below snowpack all across the state of Colorado. And it's something for us to really pay attention to. Here's our flows. We have flows at Steamboat Springs here, below Craig here, and at Deer Lodge Park, again, our lowest river flow gauge on the basin. We did just hit peak more or less here in Steamboat on the Yampa, which was really exciting for all those recreationalists. It's nice getting on the river and having fun. But we do see trends of the water now tapering off. So these are our forecasted trends, what's going to happen in the river, on the Yampa, Elk, and at Deer Lodge. So we're more or less forecasted to now be on the descending limb of the hydrograph. And back to this map, guys, and I'm going to more or less leave you with this one is where do we go this year? You know, here we are with our drought predictions and where we are today. And it's going to be an interesting summer. And what's it going to hold? Fortunately, we have a lot of smart people out there working on these. Groups like Friends of the Yampa, working on this Yampa Basin Rendezvous, folks at our Yampa White Green Basin round tables, the Upper Yampa Water Conservancy District, the City of Steamboat, the Nature Conservancy. I could go on with how many great people are working here on the Yampa Basin for dealing with this specific issue. You know, our base flows get so quickly down, and climate's getting hotter. We know it's getting warmer. So fortunately, there's a lot of momentum, and there are a lot of people who are coming and focusing in on the Yampa Basin. You know, the Center for Western Weather Water Extremes is looking here, and we really appreciate all your support. It's awesome. Without the help from those reservoir releases, you know, that's great. We're doing We have climate resiliency in place. We're trying to cool our river with the in-stream flows as well as the retree. We're planting plants, and I think we're setting ourselves up for a really good place for our future, which is hotter and drier. And then last thing, we had a great successful effort to put together one of Colorado's first river funds, and it's called the Yampa River Fund. I'd love it if everybody could go check that out at the end of this, yampariverfund.org. It's set up to help grant money to efforts similar to what we're working on right here. So with that, thank you, everyone. We'll go into Q&A now. Thanks, Nathan.
Excellent. Thank you, Kent. I'd like to invite you, Kent, and Marty to join all of our webinar attendees here for a question and answer session now. So I'm going to welcome my fellow steering committee member and colleague, Lindsay Marlowe, in to help host this Q&A session. Lindsay's with the Yampa River Fund, just mentioned. So welcome, Lindsay. Feel free to take it away.
Great, thank you, Nathan. So we have opportunity if you guys would like to answer or ask questions, please raise your hands now or feel free to type in the Q&A box. We have a few questions up here. One is directed at Marty from Becky Bollinger. It says, the difference between rabbit ears and tower are striking. I wonder if they would also show noticeable differences between the low and mid-level wind directions during these wettest events. I.e., do they require a different wind direction for upslope?
Yeah, great question. And I'm certain that's part of the story, but we can analyze that when we set up the analysis path properly. We should be able to diagnose that. And Kent had some real insight in that when we were talking about it the other day, how the sort of local knowledge is that rabbit ears is more vulnerable to or sensitive to the upslope storms in the spring, which are often what hit the front range. January, February are bone dry in Denver, but March and April can get quite wet. So I think that's a really good direction to take in the analysis.
The next one is from Douglas Alden, and it says, how frequent are late spring, early summer snowstorms?
I think I'd turn that over to Kent.
Yeah, I've been living in Steamboat since '94 here in Northwest Colorado, and that would be a great, doing these rendezvous and these conferences, we just get more questions. So I know Marty's probably writing that down and thinking about that one, but just from living here and knowing, last year was definitely an anomaly. I don't remember getting a snowstorm in June since the early 2000s. I don't have data to back that up, but we do get snowstorms. Like I was skiing this year. We had some good snowstorms early May. So they do happen. Again, a nice detailed approach with some science behind it would really answer that question for us, but it does happen.
If I could add to that, Kent, we had a scientist visit from University of Utah, Jim Steenberg, gave a seminar on seasonality of extreme precip in the West, and spring was one of the most variable was the most variable season. In other words, some years would just be no action really from an extreme precip standpoint, and others were very active. I think a lot of the climate analysis and work is really centered on the summer and winter seasons, where the winters where we get most of the snow and rain. And summers where the heat comes in and maybe we get the monsoon. The shoulder seasons of spring and fall have received relatively less attention, and it's a direction we want to head in terms of our research efforts.
Thank you, guys. We have here, next one is from Mike Dedinger, and it's more of a comment, but I guess you guys can address the comment. It says, perhaps not so relevant to this particular forum, but these northwest paths for ARs are getting into Northwest Colorado seems extremely likely to also clip the northeast corner of Nevada. The Ruby Mountains and Humboldt Range up there are, to some mysteriously, the very wettest part of Nevada outside of the Sierra. If this hypothesis is right, there should be a correlation at storm and water year levels between flows in the Yampa and the Humboldt River in Nevada. the longest and one of the largest rivers in Nevada.
Yeah, I think Mike Dettinger's right on there. Interesting. I'm not familiar with that, terrain, but it makes a lot of sense. There could be a connection there. Something, and Mike's, joined up with our center. We'll do some work on that over time.
The next question is from Kelly Romero Haney. It says, what additional data do you wish we were collecting on the Yampa River Basin?
Soil moisture.
Precip from rain. Temperatures on the Yampa, more detailed temperature plan.
I think winds aloft. There's technology called wind profiling radar. The question Becky Bollinger asked about the wind direction. It'd be wonderful to have observations of that. Radiosondes are another way to do that in a field campaign mode.
Great. And the next question is from Douglas Alden. Why do drought maps so cleanly stop at New Mexico border without spilling into Colorado?
I don't know.
Yeah, I don't know. That's a good question.
Maybe that's something we can address in the post question answers that we have on our webpage. The next one is from Grayson, and it says, has the influence of the Elkhead Mountains on the patterns been explored?
I've been really curious about that personally, but we haven't gotten into the detailed analysis yet from our perspective. But I imagine, Kent, from boots on the ground, living it day and day, depending on it, might have some insight there. You get rain shadowed from the Elkheads?
I'm not 100% sure. I want to dig deeper into every storm, of course. And here and into the future, kind of seeing, it would be great to have some support to do that, to see where the wind's coming in from, because the wind really plays a big part with how our snow occurs, how our snow falls. Mm-hmm. How long the storms sit and spin with those orographics before they push on out. I have a feeling that because the Elkhead Mountains are a direct obstacle before Buffalo Pass, I have a feeling if the storms do come over the Elkheads, they're going to suck some of that moisture off before it hits Buffalo Pass.
I agree. I should add, though, I think these winds aloft thing, it just occurred to me, as you go higher and higher above the land surface, the winds get more and more uniform over larger areas. The mountains sort of chew them up at lower altitudes. But once you get up above, 15,000 feet or so, you're going to see the winds over, say, Hayden are probably pretty similar as the winds over, Steamboat. And that's not a bad altitude to be looking at. And down at 10,000 feet as well, although they're going to be diverted by the mountains a bit. It makes me wonder if a wind profiling radar at Hayden Airport might be a good location from a weather standpoint, and with the added advantage that the measurements would likely be quite useful for aircraft operations. Wind profilers around the world, some of them, they are located sometimes at airports because the aviation industry finds those data very useful. They measure the wind, the vertical profile of the horizontal wind every few minutes, at say a few hundred feet, a couple hundred feet, levels, all the way up to 10, 20,000 feet, depending on the radar. And that can be very helpful for aircraft on approach or departure and that sort of thing.
Great. The next question is from Mike Gusev. It says, has anyone taken a look at how water quality and fluxes of solutes and sediments change and sediments change downstream in response to these extreme events?
I imagine people have to a degree, but we're not doing that kind of work. And as a meteorologist, I'm not very aware of it. Kent, do you know anything?
I don't. That would be a question for our friends up at the Storm Peak Lab, among others.
Mm-hmm. Hey, if I could interject for just a moment, I do have one more slide I failed to show that I really would like to show. It's a people slide, and it's sort of a nice way to close a little bit. Would you be okay if I shared my screen for one moment? So I wanted to let you know that Madison Muxworthy has joined our summer internship program sponsored by CW3E. We have 6 or 7 students this summer. They're undergrads, and Madison applied, and based on our YBR connection was a good application. And we line up undergrads with mentors. And here you see on the right, Mike Sirks, who's one of our key planners of YBR on the committee, is a PhD student here, and he's a primary mentor. And also Anna Wilson, Dr. Anna Wilson, who's on our steering committee, and she's their field research manager at CW3E. And Michelle Olsgaard Stewart from Steamboat, executive director of Yampa Valley Sustainability Council, are all coordinating to help mentor Madison in her summer internship program. And I just really wanted to say congratulations, Madison. It's great to have you on board. I know it just started this week, so good luck going forward.
Thank you, Marty. That's very nice of you.
You're welcome.
Congrats.
We have about 4 more minutes and 3 more questions. Do you think we can cover them quickly?
Sure.
One is from Michelle, and it says, what can agriculture water users learn from this data?
From the AR data specifically, or, from a drought standpoint, I guess the take home is, and the ag folks know this, we've had ag production for over 100 years in the Yampa Basin in Colorado in the West. They know that they're never out of the weeds, so to say, even if they get a good snowpack. Fortunately, last year was a good ag production year, even though we did have those late seasons droughts. So they do have to plan their agricultural production based around snow and water data, obviously. Any way ARs can help with that?
Well, part of the goal for our rendezvous this year is the subseasonal to seasonal prediction. Subseasonal, think of that as like 2 weeks out to a few months, and seasonal is, of course, seasons, months. That if ARs are an important, just like in California and in some parts of the West, we're starting to look at, the variability in annual precipitation from year to year is driven by the number of ARs. It's those top few wettest days each year. Some years we get a number of them and we're above normal. Some years we don't get enough and we're below normal. So one of the things we're exploring is, to what degree are these few wet periods, extra wet periods each year, a determinant in whether it's a wet year or a dry year in the Yampa Basin. And if it is, then, and my instinct says it is, that then it points the question for predicting down to basically predicting those type of storms that produce those very wet periods. And ARs are looking to be part of that equation, but we haven't really done the full analysis to say yet. And it's a really good question, though.
Do we want to take the time to address these last 2 questions?
Sure.
Okay. Derek, I'm sorry if I say this incorrectly. Myolo, how is the local area responding, bracing for this 20-year drought that some experts are calling the new normal? What are top things that need to be done to protect the basin and industries that rely on local water?
That's a big question. Thank you for that. Locally, I alluded to it. We have the reservoir releases in place. We're planting a legacy riparian forest to help cool the river down. We've created the River Fund, which allows us to allocate monies on an annual basis for projects, not only agriculture, but environment and even rec. So we're doing a great job. We have folks like CW3E and other academic institutions focusing in on the Yampa Basin, and that's specific here to the Yampa. So I think we're setting ourselves up pretty well here for climate resiliency in our basin.
I don't have much to add for that, but it's certainly a very important question. I would like to interject that we're just about to the end. It's 11:30 right now, Pacific time, 12:30 your time. I think out of courtesy to our participants, we might want to offer some closing remarks. I don't know if Nathan or anybody else has anything, but we have more webinars coming up this summer, and I'll mention that we're thinking seriously about doing another YBR next year, hopefully in person. But I'd like to suggest we close the meeting. I have to get off the phone in just a moment myself.
Excellent. Thank you, Marty. A final slide here. First, thanks again to Marty and Ken. Excellent conversation in this final session. There were numerous meaningful questions raised. This is the central goal of WebYR. So final slide here. And Anna, perhaps I could have you advance if that's okay. And you're welcome to land on the next slide, our final one. So we'd like to highlight our forthcoming webinar in this year's dialogue. Our June 9th panel convenes an exceptional group of scientists at the leading edge of snow, weather, and atmospheric science. We look forward to presentations and conversations with Jeff Deems, Mike Dettinger, and Gannett Holler. Please find information on this event and event registration at Friends of the Yampa. Thank you again, Marty, Kent. Our sincere thanks to you, Carrie, for joining us here today and kicking us off in this year's dialogue. Our best to everyone, and we look forward to seeing you next month. Thank you.
Thank you.
Thank you all.
Have a good summer.
Be safe.